So here I will be telling about my final project that is under supervised by Dr. Mohammed Adinata. That is material and design selection of an acid filament for the sharpie antenna using hybrid method. So in this study I explored that NFC or natural fiber composite as sustainable alternatives, especially here in this case for sharpie antenna with the growing concern recently for our environmental impact, the sustainability of manufacturing. So actually the NFC or natural fiber composite offers a promising solution because it is more biodegradable, which means that when they are no longer used, they will be break easily and it's safely in terms of our environmental. And it is also strong compared to other materials. And as you can see that it is also friendly and it is combined so there are three objectives in this study. The first one is to analyze the mechanical properties of the acid filament, and the next one is to evaluate the conceptual design of the sharpie antenna using a hybrid method. The hybrid method here means the CAD and the criteria manipulated. And the last one is to fabricate the sharpie antenna using fused deposition model. So the steps that I used during this study, during this project, is the first one is to read and study about the literature or the previous studies based on the tutorials before, and right after that design the specimen based on UTeM, the American Standard Material Testing, which is E638 for the tensile and E790 for the flexural testing. And after that to print the specimen and then to test that for the tensile testing and also flexural. And right after that, at the same time, I also designed three designs for the sharpie antenna to see which one is the best based on top 6 method, as you can see here. So before that, I obviously did the FEA or to simulate using the SolidWorks simulation, and at the end to fabricate the sharpie antenna. So several points here about the literature review. The first one is that NFC, as I mentioned before, it is more lightweight and biodegradable and strong. And also PLM is more compatible with the fused deposition modeling. And for the next one is about the sharpie antenna. Actually, sharpie antenna it is commonly used by made of ABS plastic, as you can see around that, especially in the car system. They are made of common thermoplastic polymer, which is ABS plastic. But MPS is present a greener alternative. And the next one is the criteria decision making that I use here is top 6 method instead of other common methods like Ropic or Fuzzy. And it is because top 6 provides a clear and visually interpretable ranking of alternatives in terms of ranking of the decision making. So that's there's one thing missing here actually. The velocity that I applied on this in this study, it is actually 90.50 km per hour. It is based on the real vehicle data from the previous study. So that's about the velocity that I applied for the simulation for the initial course. So here, as you can see, there is one table and one figure. The table here is actually for the material selection. I'm sorry, for the design selection, and this one is for the material. So based on the top 6 from these 3 designs, I use the flow trajectory and also surface pressure simulation. It shows that the design is actually the best design based on the aerodynamic performance, air force, coefficient rate, and also surface pressure. With the numbers here, as you can see that the lowest air force is from design 3, which is 0.457 Newton. That leads to the lowest air coefficient, which is 0.250. And for the design 1 and design 2, as you can see that there. But the design 3 is actually not that big difference with the design 1 and design 2, the other designs. It is actually only 1.018 bar, the surface pressure that happen on the surface pressure. So based on that, the performance score, here as you can see, the highest one is design 3, 0.991. That makes the design really as the best design compared to the other designs. Okay, so for the material selection here, I did the flexural testing and also tensile testing. So for the tensile testing, the result here is tensile strength and also the I had the numbers, I rounded the numbers to 1 digit after one decimal, so that can be easily seen here. So actually, there are two PLA woods here, as you can see. So the PLA wood 2, PLA coconut, and PLA bamboo is from the previous studies. I already said it on my paper. But the PLA wood 1 is the one that I brought from Indonesia. I brought it from Indonesia. So I wanted to compare. I wanted to see whether it is the same in terms of mechanical properties of the PLA. So as you can see here, I did the flexural tensile. It shows that the PLA 1 shows the highest tensile strength, the modulus, and flexural stress also the modulus. And so yeah, in conclusion, I use PLA wood 1 as the best material, but on top of that, also the design fee. And as you can see here, so I think
very good presentation. But I have a few questions to ask. The first one is, why you choose the shark fin antenna in this project, in this assignment? Why the shark fin antenna is focused in the study? This is about the material, right? So why the antenna is used?
Why did I choose antenna as the automotive part? It is actually nothing related to the supervisor and everything, because actually I had the internship at the Yamaha company and I asked about this one, that I'm going to have project about this, the automotive part. Do you have any recommendation? So it has nothing to do about that. And I also wanted to learn about the aerodynamics or the fluid simulation, because since I have never learned more about the aerodynamic simulation and everything with fluid dynamic simulation or SolidWorks. So yeah, might as well. I wanted to learn about the aerodynamics. So far, I know about the force simulation, and yeah, just like
During your simulations, do you realize that is how much the aerodynamic force given to the shark fin in dynamics? The maximum aerodynamic force, I mean, the force given by the aerodynamic to the shark fin during the dynamics.
all the designs.
Yeah.
Here on the poster, actually the result only shows the drag force for design. It is the lowest one, 0.457, which means that with the velocity of 25 meters per second, the drag force which goes back to the shark fin is actually only 0.400 newton or 400.
So which one is the lowest value?
This one is design. Actually, these designs based on the commercial ones that we have.
This is what kind of vehicle that is this kind of shark fin? In your research, is based on what kind of vehicle? Before this, you internship in
But it's not automatic, the one that is called.
Okay, if I'm not mistaken, you said that the test, the velocity of the vehicle, the test in the CFD, right? Is about 90 kilometers and so on. 90 kilometers, the speed of the vehicle is 90 kilometers. Okay, why you choose 90 kilometers per hour?
Just because I wanted to see the real situation in the maximum one, actually.
No, that is not the maximum one. Yes. Contohnya, dalam vehicle dynamics, you have to know there are 4 types of speed of the vehicle. Maksudnya dia apa kita panggil standard. Dia standard. Macam the most available, gitulah standard lah, satu lah standard lah. Dia lah 0 to 40, today 0 to 40, 40 39, 40 to 59, 60 to 89, SCR, 90 to 110. You choose 90, ini adalah satu speed yang common speed tau. Saya tak kalau saya katakan, ini Indonesia punya speed lah. Tapi dekat Malaysia orang tak dengar kata. Nangkai dia orang pada tak. Betul. Kuping ni orang kata kat sini. Sebab when they are going to drive the vehicle inside the highway, then for sure the driver will speed up to 120 up to 150. So 90 km per hour memang macam it's not relevant to Malaysian drivers. You just say this is the Indonesian punya style tau. Sebab Indonesia maybe I'm not sure kalau dekat jalan tol berapa speed boleh pergi.
Over than 100.
Over the 100 kan?
20 km per hour.
Yes. Kalau you just design based on this kind of speed, ini masih okay aja. Masih okay. So the thing, what do you think about the design? Dengan speed yang boleh tak saya katakan that you are not test in the maximum conditions? Boleh tak saya katakan macam tu?
Because it is not the maximum.
Yes, kalau 90 km per hour itu dekat Malaysian punya driver, tapi dekat dalam persekutuan, maksudnya without toll. Tapi kadang-kadang, bukan kadang-kadang, most of the people, saya lah juga, kadang-kadang line play saya pacak cukup-cukup 120, 130 kan. So, saya kira untuk the condition, luar daripada Indonesia, condition ini tidak terpakai. Sepatutnya dia punya speed standard speed limit. Okay, national speed limit. We call it is national speed limit. National speed limit. Walaupun dia ada bagi speed limit, tapi most of Malaysia tak dengar kata. Degil. Apa yang jawab itu? Jawab apa?
Goblok.
Bandel.
Aku tahu goblok.
Tapi most of the people tak dengar kata. Line clear saya boleh tengah malam, kita kat Malaysia kan, tengah malam saya boleh bawa more than 90 km per hour, 110, even though dekat jalan persekutuan, dekat dengan sekolah. Boleh tak jadi dengan kata-kata itu, saya boleh katakan, boleh tak saya katakan bahawa this is not bukan valid untuk this condition, tapi untuk maximum condition tidak di
Because the previous one, actually, this data is the latest one that I got because it is actually quite hard to find the velocity. So once I have the journal about the velocity, the maximum velocity is only 90.50. So I cannot use other velocity.
Okay, that's right. Memang based on the journal, you have to use the kind of speed. But you can say that saya nak test nilai yang lagi maximum. Condition we can test untuk case yang lebih maximum.
So even though the journal doesn't say I can apply.
Kalau you want, the new one, basically there is a new contribution.
Okay, pada namanya future study.
Yes. Jangan kami macam. Saya pun cakap baik-baik.
Kau kata kekal. Dia kan kata kekal.
Okay, what does it mean by toxic? You just said toxic, but I don't know what does it mean by toxic.
Order preference, recommendation to ideal solution. The theory is stable, I guess. Okay, this is the method.
Okay, what does it mean by PLA and movement? PLA says one. What does it mean by the material?
It is a composite combined with
Maksudnya combination tapi pendek kami satu. Okay. Okay. When? Is it the punya material can be similar? In this
oh yeah, I do the toxic for the legal
you can simulate the type of this kind of composition by using the center to the figure.
calculation.
Okay, tapi they have misalnya dia kena model dia sharp fit kan. You have to write the challenge before.
Orang memang perlu design secara jadi itu top betul pilih. Material yang mana?
At the end, by using that material, then they have to design. then it is fabricated or just fabricated. Then after
Installed on the server. Installed on the car.
ini dah fabricated lah.
So it is
Dia ambil all the design on this dia ambil. Okay. I mean how to
Ada
test
design.
Ada.
Boleh tengok?